So in Chapter 1, we're going to be studying quadratic functions. Here we're going to be looking at quadratic functions in standard form, and our learning objectives are going to be to graph these quadratic functions. So a quadratic function in standard form has a root equation, y is equal to ax squared, and the full standard form is y is equal to ax squared plus bx plus c. So when you look in the root form, this is a case where the coefficients b and c would be equal to 0. And as we explore the difference between this form and the root form, we can glean the impact that the coefficients b and c have to graphing the program. Key vocabulary for this section include the concept of what a quadratic function looks like, the shape of the graph of a quadratic function, which is a parabola, the vertex of a quadratic function, which would be the highest or lowest point on the quadratic, or if you think of the parabola as an item that starts off going either up or down and at some point changes direction, the vertex is the point where it changes direction. The axis of symmetry is an imaginary vertical line that splits the parabola in half. It is a vertical line that passes through the vertex, and the parabola itself is symmetrical on the right or left side of this line. Minimum value would be the vertex for a parabola that opens up, and the maximum value would be the vertex for a parabola that opens down. When we look at quadratic functions, a quadratic function could be helpful in helping us solve a problem that looked like this. So we're going to frame the lesson around the concept of we would like to solve this problem with the assumption that we don't quite have the skills to do that yet, and as we go through graphing, we're going to eventually arrive at a place where we can solve this problem. So the concept here is someone who owns a go-kart track, currently gets 380 racers per week and charges $35 for each race. The owner estimates that there would be 20 more racers per week if he discounted the price $1, and another 20 if he discounts it $2, and so on. So the question is, at what point in time will he make more money? How much should he lower the price, or raise the price for that matter, to maximize the amount of money that he makes? So we're going to address this problem as we get to the end of this section. So here are some key concepts that are going to review our vocabulary point. Again, we discussed the axis of symmetry. This is the graph of y is equal to x squared. The axis of symmetry is a vertical line that passes through the vertex of a parabola. This point here is the vertex of the parabola. Because this parabola opens up, the vertex you can see is the lowest point of the parabola. If the parabola opened down, the vertex would be the highest point on the parabola. Okay, so and this is the graph of y is equal to x squared. If we go through graphing, there are a number of different ways to go about graphing. We could make an input-output table and graph, but you can see that with a parabola, it might take many points for me to be able to figure out exactly where my parabola lies. So just randomly selecting points might be a little difficult. If we go back to looking at the root form, you can see the vertex for the root form is always at 0, 0. Since I know the vertex is at 0, 0, I know that my axis of symmetry passes through that line, and I've got half of my parabola to the right and half of my parabola to the left. So I know, because I'm in root form, that my vertex is at 0, 0. And now that helps me define what points might I want to plug in to create an input-output table. So I'm going to pick 2 points to the right of the vertex. So in that case, x would be equal to 1 and x would be equal to 2. And when I plug these items in, 1 squared is 1 times 5 is 5. 2 squared is 4 times 5 is 20. And if I go ahead and start to graph that, 1, 2, 3, 4, 5, this point here is 10, so 20 would be way, way up here. So I can see that this item is going to carry on vertically very sharply. Right? It's going to end up being at about 20 all the way up here. So somewhere up in this direction, I will have the point 2, 20. Right now, this is my axis of symmetry. I know that whatever has happened here on the right side of the axis of symmetry, it will be matched on the other side. So if I'm 1 point away from the axis of symmetry to the right at 5, I can go 1 point to the left and be at 5. And over here, 2 points to the left would be -2. I would also be at 20. Right? So I really don't have to do an input-output table for the other side of the parabola if I don't want to. But you can also see that if I were to choose those points, -1 and -2, right? This is -1, 5, and this is 1, 5. So you'll notice that the inputs are the same distance from the axis of symmetry, and the outputs are the same. So if I plug -1 into this root form, -1 squared is 1 times 5 is also 5, and -2 squared is 4 times 5 is 20. So if I would like to graph a parabola, I locate the vertex, and then I can plot 2 points to the right or left of the vertex, whichever I prefer, and then match to the other side using symmetry. So if we look at another example, in this case I've got a leading coefficient, or an a value, that is 1/3. It's good to work with fractions. It's still in root form, so the vertex is at 0, 0, I know that. And I can still pick 1 and 2 as my inputs, 2 points to the right, 1 and 2. 1 squared is 1 times 1/3 will be 1/3. 2 squared is 4. 4 times 1/3 is 4/3. And if I plot those points, 1/3 and 4/3, which is 1 1/3, and I can match them on the other side. Again, my axis of symmetry is a vertical line here. If I'm 1 point to the right of the axis of symmetry at 1/3, 1 point to the left would also be at 1/3. 2 points to the right and I'm at 4/3. 2 points to the left will put me at 4/3. And as we come through here, this is the shape of this parabola. Now you'll notice that, and this is how will help us determine the impact of the leading coefficient A on the parabola. Here my leading coefficient is 1/3, and you can see my parabola is very open. It looks a lot like an umbrella. If we go back to the previous example, my leading coefficient was 5, a much larger number, and you see it's very, very narrow, more like a rocket ship. Okay, so the larger the leading coefficient, the narrower the parabola. The smaller the leading coefficient, the wider the parabola. Okay, so that's graphing quadratic functions in root form. Now we're going to get a little more complicated and use the full standard form. So our full standard form is y is equal to ax squared plus bx plus c. Again, the minimum value of the function, right, the vertex is the minimum value if a is greater than 0, meaning a is my leading coefficient. If it's greater than 0, meaning a positive number, right? And the maximum value, it's the maximum value, the vertex is the maximum value if a is less than 0, meaning a negative number. So the important item is, if a is negative, my parabola opens down and my vertex is the maximum value. If a is positive, my parabola opens up and the vertex is the minimum value. I'm really quickly taking a look at the effect of different changes. If I increase the value of my leading coefficient, you can see that my parabola narrows. If I decrease it, you see that it widens, and then eventually, when the leading coefficient is 0, it becomes actually a flat line. And when it's a negative number, you see that it flips over and it opens down. Okay, so what is the b value going to do? Right? Oh, look at the b value. So the b value, you see, moves my parabola right and left, and the c value moves it up and down. Okay, so A determines width and whether it opens up or down. B involves moving the item to the right or left, and you can see there's more at play. C also then moves it up and down. Okay, so those are the impact that A, B, and C can have as we change from parabola to parabola. Right? Now, if I want to work with this full form, I'm not in the root form, so my vertex is not at 0, 0. And remember, the first thing I wanted to do was to find the vertex. Well, remember, the vertex is going to be related to this value of b, the x-coordinate, right? Because that determines right and left. Okay? The right or left positioning of my vertex will be determined by the b value. Now, here, let's make sure we understand that we're looking at the right numbers. A, in this case, is equal to 3. B is equal to -6. And C is equal to 4. Okay? B and C provide very important parts. Now, C is always going to be the y-intercept because y is the value when x is equal to 0. So the y-intercept is the value when x is equal to 0. And when I plug 0 in for this x value and this x value, these will both become 0, and I'll just be left with that. So I know one point is right here, 1, 2, 3, 4. Right? In any function, regardless of the type, in this case quadratic functions, if I plug 0 in for x, I'll find the y-intercept. Now, if I want to find the vertex, I'm going to take this b value, and I'm going to use this formula. Right? The x-coordinate of the vertex can be found by taking the opposite of b divided by 2 times a. Okay, so if I take the opposite of b, the opposite of -6 is 6, and 2 times a, or let me be more explicit, it's the opposite of -6, so I've just taken b and plugged it in, I've taken a and plugged it in, and I have the opposite of -6, which is 6, over 2 times 3, which is 6, so it will be equal to 1. So I know that my vertex is somewhere along in here, and I know that I have an axis of symmetry that's going to vertically pass through that point. So there we go. That's our axis of symmetry. Now, if I want to find the value of y when x is equal to 1, I just make an input-output table. I plug it in. 1, right? We'll go ahead and plug it in here. So I'll have 3 times 1 squared minus 6 times 1 plus 4. So 1 squared is 1 times 3 is 3 minus 6 times 1 plus 4. 3 minus 6 is -3. -3 plus 4 is 1. So my vertex is right here at 1, 1. I already did the easiest plug-in, which is plugging in 0 for x. I know that I'm at 0, 4, right, which gives me this point. And if I choose to pick -1, I will have picked 2 points to the left of my vertex. So if I have 3 times -1 squared minus 6 times -1 plus 4, -1 squared is 1 times 3 is 3, minus 6 times -1, that's minus -6 is plus 6, plus 4, I'll have 13 as this value. So again, it's going to be up off my grid, probably somewhere up about here. If I use symmetry, I can plot this point over here. Remember, again, same distance from the axis of symmetry, and the same y value. And the same up here. And this is going to be our graph. Our vertex is the lowest point on my graph, and it's at 1, 1. Let's do another example here. So let's start off by identifying our coefficients. So A in this case is -1, B is equal to -2, and C is equal to -1. Remember, C is always my y-intercept, so I can go ahead and put that right in. So I have the opposite of -2 over 2 times A, which is -1. The opposite of -2 is 2, divided by 2 times -1, which is -2, will be equal to -1. So that's the x-coordinate of my vertex, -1. To find the y-coordinate of the vertex, I plug it into my equation. So I'll have the opposite of -1 squared minus 2 times -1 minus 1. So -1 squared is 1. The opposite of that is -1. Minus 2 times -1. So minus -2 is plus 2 minus 1. -1 plus 2 is 1. 1 minus 1 is 0. So I'd be at -1, 0. I want to find another point here to the right of my vertex. But first I'm going to put in my axis of symmetry. It travels right here vertically through the vertex. Okay. I'm going to go ahead and plug in the number 1. So the opposite of 1 squared minus 2 times 1 minus 1. 1 squared is 1. The opposite of 1 is -1. Minus 2 minus 1, and this is going to be -4. So over at 1 I'll be at -1, 2, 3, 4. Again, using symmetry, I'm 1 away from the axis of symmetry at -1, so I do the same on the left-hand side. 2 to the right, I'm at -4. 2 to the left, I'll be at -4, and this is my parabola. Okay, so remembering when the leading coefficient is negative, the parabola opens down. When the leading coefficient is positive, the parabola opens up. And now let's go on and solve our go-kart problem. So the key here is we're going to need to put together a model that will relate to this concept. So I know that right now I can think that the amount of dollars that this fellow is going to get is going to be the price per ticket, right, times the number of racers, right? So the price he charges each racer times the number of people who come in. So right now he has 380 people coming in, and he charges them, I'm sorry, I did that backwards here. Let me make them match the way they ought to. He's charging $35 per racer, and he's got 380 people coming. So now the question is going to be what will happen. He estimates that I get 20 more racers each week for every $1 that I reduce the price. So if I want to put that in a model, right, this price reduction, right, is however many reductions we do minus 1. So if I look at my price, I can model that by $35 minus the dollar change, which is $1, right, times the number of times we reduce the price. So X is going to be the number of price reductions. Okay, number of price reductions is X. So the price I'm charging is $35 minus the number of times I've reduced by $1. The coefficient here is really this $1, but we don't typically write coefficients that are 1. My attendance will be the 380 people we started with, plus, right, and it's plus because it's 20 more racers, plus 20 times X. Okay, and when we go through and we solve this out, if I multiply this all out, I'll end up with my equation in standard form. Okay, so y will be equal to, if I use FOIL, right, and I'm actually going to reorder this a little bit because right now my x's are last, and I want my x squared first. So negative x times 20x would be minus 20x squared. Negative x times 380 is minus 380x. 35 times 20x, that's plus 700x. And then I have 35 times 380. 13,300. If I simplify this, I'll have negative 20x squared. I have minus 380 plus 700. That's going to be plus 320x plus 13,300. Now at this point, this would be an excellent point for you to go ahead and whip out a graphing calculator and go ahead and plug this in. I can go ahead and look at my, right, I'm looking for, right, we know that this opens down. If I think about the parabola, it's going to look something like this, right? I know it opens down because the leading coefficient is negative. That means that the vertex will be at the highest point here. And what is this graphing? This is graphing the total amount of money. So this point up here, this is the point where his revenue is going to be maximized. So I really just need to know, where's the vertex? Okay, so if I take the opposite of B, so the opposite of 320, divided by 2 times A, 2 times negative 20. Right? This is going to be negative 320 over negative 40. If I cancel out a power or a 10, then I have negative 32 divided by negative 4. Negative divided by negative becomes positive. 32 divided by 4 is 8. So if x is equal to 8, remember, x is how many times I reduce my price. So I'm going to reduce my price by 8. So my price is going to be 27. $27 is going to be the best price for me. If I want to go ahead and find out how much money I make, I would take 8, I would plug it back up into this model in place of x, and I'll get the actual revenue. The key thing I wanted to do is find out what price should he charge. $27 is the price that is the best price for him to charge. One important thing to remember in this, the last thing you always want to check when you solve a word problem. What we did is we took this information, right here I created what was called basically a verbal model. So I did a description of what comes into play. The total amount of money I have is the price per ticket times the number of people who race. Right? I then went ahead and created an equation. Right? Based on the supplied information, we were reducing the price by $1 each reduction, so that was 35 minus the number of reductions, 1 times the number of reductions, and that would increase our ridership from 380 plus 20 times each reduction. When I multiply these together, it creates a quadratic function, and I go ahead and formulate it. But you'll notice that my answer here is 8. 8 is not an answer to the question of how the owner of the go-kart track maximizes weekly revenue. What it is the answer to is how many price reductions do I need? So the answer is, how does he maximize weekly revenue? By reducing his price to $27. Okay, so make sure once you've correctly created a model, solved your model, the solution may or may not be the answer to the question. Frequently, like in this problem, it's a piece of the information that you need in order to answer the question. Okay, that's a wrap up on section 1.1.